Recording in progress.
Okay, so hi, good evening, and welcome to my new class. Today we are going to discuss about what? Projectile motion, right? Projectile motion. So before starting the projectile motion, I would like to just make you remind one thing, that is motion in one dimension. So we have learned there about some equations like v equals to u plus at, s equals to ut plus half at square, or v square equals u square plus 2as. So basically these all formulas will be used here in motion in 2D. And projectile motion is basically you can say it's an example of motion in 2D. Okay, what is the example of projectile motion? Say a footballer kicks a ball. Okay, the ball will move like this, or suppose I am throwing the object like this. See, it's motion. These kinds of motion, that means when a body is projected or thrown with making some angle with the horizontal or maybe in vertical, that means this kinds of motion is called projectile motion. So let me just introduce on a board so that I hope it will be a clear idea for you. Okay, so okay, students, so please be with me. Let's start. So we are going to discuss about what? Projectile motion. Okay, projectile motion. Okay, yeah, projectile motion. Basically, there are different kinds of projectile motions that there, like horizontal projectile motion, oblique projectile motion, more projectile motion on an inclined plane. So now I am going to, for today's topic, is oblique projectile. That means oblique projectile or oblique projectile. What is this oblique projectile? It will be very clear idea for you. Just, yeah. So what I have just said, no, say it is an object, suppose a football. Okay, this is a football. A player kicks the ball. Okay, a player kicks the ball from here. So its motion will be something like this. Just a minute here. It's like this, right? Can I say the ball? See, that means the player hits the ball, which making some angle like this. If I take this as an axis, this is the x-axis, we know horizontal axis. This is the vertical axis, y-axis. Now see, it's making an angle, right, with the horizontal. That means when it makes some angle, what will happen? Already we have learned in vector, always a vector which is making an angle with the horizontal or vertical, it has a two component. One along the direction of x, that can be written as ux. And you know what is the value of ux? Please, yes. Yes, all? Yes, it is u cos theta. Great. And along vertical, it is uy, that is u sine theta. Correct. Okay. So now what I've said, we got two components. That means two component of velocity. One is along horizontal, another is along vertical. So what will happen after that? When the ball or the object reaches at this point, say a point P, okay, I'm using different colors so that it will be easier for you to understand. Yeah, suppose at this point, again, velocity is look like this. It has some different value. Say I'm taking it as a V. Again, V has two components. One will be along the horizontal, another along the vertical like this. Yes, sir. Right? That means at any points, the components will be changed as well as the velocity definitely. Right? It makes some different angle here, suppose alpha. So again, it will form V cos alpha. This will be V sine alpha and so on. And when the object reaches this height, that means this is the maximum height. Suppose this is the ground level. Okay. So what will happen when it reaches the maximum height? That means it has only one component. There is no vertical component, isn't it? There is only one component, and that is only horizontal, Vx. There is no Vy here, because we know when an object is thrown vertically up, if this is an object, okay, and it thrown from a certain height, right? So when it reaches the maximum height, say the height is h. So what will happen? Its vertical component or the velocity at this point is zero momentarily. For an instant, its velocity becomes zero. The same thing happened here. That's why Vy is zero. I hope this idea is clear. Again, when the ball is falling down, again velocity increases like this. So one thing is very clear, when the object is moving up or the projectile is projected, what happens is vertical components decreases. See, vertical component decreases, and at this point, at the highest point, it becomes zero, just like this case. When an object is thrown vertically up, The similar case happens here also, right? Okay, now we will discuss this in a mathematical form. Let me discuss. Okay, let me start. How does it look like? Okay, so let me consider an axis or coordinate system like this. Okay, this is a x axis, y axis, and this is origin O. Now a projectile is projected from a point O or from the origin. Okay, so the projectile somehow it looks like this, just what I have drawn the previous diagram. Okay, this is the projectile. Okay, path of the projectile. Now it's projected with some value or velocity, say u. Okay, it is u, and it makes an angle theta with the horizontal. As we know, when it makes an theta with the horizontal, so it has two components. One is along this, that can be written as ux, as u cos theta, yeah, and along y, this is uy as u sin theta. Yes, fine. Okay, and this is the height of the path, right? I'm just considering this height is h. Okay, this height I'm considering as h, highest path. Now see, there are some terminology related with this. What's the terminology? First one is time of flight. We will discuss about the time of flight. Okay, time of flight means the time taken to reach the projectile from the point O to point Q. Okay, that means the time, total time in which the projectile is in air, that time is called the time of flight. I'm writing this as a T. Okay, maximum vertical height, max vertical height, that means this point. Actually from here to here I'm considering this as a h. This is the mad h, maximum vertical height reached by the projectile. Okay, as h. Another is horizontal range, that means in horizontal how much distance the projectile travels, that is the horizontal. Just a minute. Yeah, horizontal range, that can be written as r. Okay, that means this is actually horizontal range. So we will discuss on all the terminology one by one. Okay, so let me discuss. It's very simple. If we consider this point, what I said, at this point there is only vx, there is no vy. The vertical component becomes 0 at the highest point, right? Now we have a formula, that is v square equals to u square plus at, or v equals to u plus at, right? That formula is used. Now if I take along the vertical component, I'm taking only the vertical component, vertical, so that I can write vy, uy, ay. Yes sir, you can write. Now first let me write the terms. That means ux, initial velocity along x component, that is u cos theta. Yes, you have already discussed. Uy, that is u sin theta. Yes, that also you have discussed. Okay, now a, what is acceleration along x-axis? There is no acceleration along x-axis, right? Only the acceleration acting, which is acceleration due to gravity, that is minus g. Because why minus? The body is moving up, g is acting downward, so it will be minus g, right? That we know. So we will use that formula on this. So vy is 0 for this point, highest point. Okay, what is uy? It is u sin theta, sir. Yes, it is already written. What is ay? Sorry, it is y here, huh? Not here. Okay, yeah. What is ay? This is minus g. So minus g into t. So from here we can calculate t, that is u sin theta by g. That means the time taken to reach from O to H is t. Similarly, that is the time of ascent. Same time will be taken to reach from H to Q, again t. Now, so what is the total time? That is nothing but the time of flight, isn't it? Yes, that is the time of flight. Yes, sir. So t equals, can I write twice of t, small t, time of ascent plus time of descent, both are same, t. So t plus t, 2t. So t can be written as 2u sin theta by g. Are, हाँ sir. Maybe this formula is, I have somewhere seen, right? Where just imagine if theta equals to, suppose if theta is equals 90 degree. Okay, what does it mean by that? Means the projectile is thrown vertically up just like this, right? theta is 90 degree, and we know sine 90 is 1. So in that case, t equals 2u by g. And we have already learned this formula, because when a body is thrown vertically up with a velocity u, the time of flight of the body is 2u by g. See, it is the some special case of the projectile, oblique projectile. Is it clear? Okay. If it is clear, then fine. Next is what? Max vertical height. Now we will be interested on to finding the maximum vertical height. This height, okay? How much maximum distance the body can be reached from the ground level? That is the maximum height. Okay. So we will do it in the next page. Yeah. So for maximum vertical height, again the same formula. Which formula should be taken? We have already the three formula. You can take any one. Either s equals to ut plus half at square, or v square equals to u square plus 2as. It's up to you. Okay. So let me take this formula. V square is equals u square plus 2as. Yeah. Okay. Now here we are taking along the y component. So all it will be y. So what is Vy? 0. Yes. What is Uy? It was u sine theta. Yes, sir. Whole square. Okay. Minus 2 into g, because ay was minus g, that's why. And the height is taken as h. Okay. Now see how much very simplified form. It is 2gh is equals u square sine square theta. Yes, sir. So what is h? It is u square sine square theta upon 2g. Yes, this is the height, maximum height reached by the projectile. Okay. Maximum vertical height reached by the projectile. That is a very important formula, you should remember. Okay, sir, fine. Now, let me discuss about the range of the projectile. Okay, horizontal range. Range, or we can say it is horizontal range also. Okay, what is horizontal range? Horizontal range is nothing but, see, now we are considering along x, because horizontal means it is along x. Let me show you this distance, see, right? So I'm considering when the body is moving horizontal. Okay, so in horizontal, can I say s equals ut uxt plus half at square axt square? Yes, sir, you can say. Fine. So x equals to, what is u here? It is u cos theta. Okay. And what is time? Can I write? It is capital T, because the total time to reach from O to Q, just like this. I'll just show you again. This, right? This is nothing but the range R, and the total time taken is T, capital T. So that's why I have written here capital T. And AX, no, it is 0, because already I have seen AX is 0. Okay, so this X is nothing but R here. So R equals to U cos theta. And the value of t we have found, it is 2u sine theta by g. Yes. So r is equals u square, and 2 sine theta cos theta is nothing but sine 2 theta. In trigonometry, you have learned it. It is sine 2 theta upon g. So this is the range of the projectile. Okay. So we have learned three things: time of flight, maximum height, as well as range of the projectile. I hope till this it's clear. Okay. And easily from this also we can find when the range is maximum. Okay, let me show you. It's very simple. R will be R max. Okay. Range will be maximum. When it will be maximum? A term related to sine or cosine will be maximum if that sine or cosine is 1. Because we know the maximum value of sine is 1. So sine 2 theta must be 1. And when sine 2 theta is 1, sir? When 2 theta is 90 degree. Yes. And 2 theta is 90 degree means theta is 45 degree. So can I say, sir, that R max is equals to u square by g? Yes, sir, we can say, because sine 2 theta is 1 for the maximum range. So this is the maximum range. And when the range maximum will appear? If the projectile is projected at an angle 45 degree like this. If this angle is 45, then the range will be max. It will become R max. This is an example of javelin throw. Okay, if the javelin is thrown at an angle 45 degree, then the range will be maximum, or for any object. If it is projected at an angle 45 degree with the vertical or horizontal, doesn't matter, because 45 is 90 minus 45 is also 45. So it may be horizontal or vertical, the range will same. Okay, class. So I hope it's clear. Okay, there are so many things we will discuss one by one, like the trajectory of the path, okay, along which the projectile is traveling. It will be a parabolic, and mathematically we can also show it. So anyway, I hope till this it's clear, right? Okay. Any other confusion, any query? No. Okay, then great. Okay, thank you so much.